Welcome to ACM Shorts. Today, let's fix that mix. The ACM short where we discuss a concrete problem, troubleshoot what happened, and offer a solution to prevent it from happening again. When pavers are required to meet ASTM C140 performance standards, some of the most important test results are density and absorption, which are critical in performance. Today we will focus on aggregate blending and its impact on density. Aggregates make up 65 to 85% of the volume of raw materials and include coarse and fine aggregates. These aggregates form the skeleton of concrete products and contribute to the overall strength, texture, color, and appearance of the finished products. It is important to blend a combination of both coarse and fine aggregates to maximize the overall performance and consistency of the units. The aggregate blend will affect the amount of cement required, water demand, and overall strength, absorption, and durability of the finished product. It is important to blend two or more aggregates in any mix design in order to compensate for any changes. Why, you ask? Because aggregates can change. Determining the proper blend of aggregates for a particular product involves several steps that include proper sampling of the aggregates, sieve analysis to determine the range and particle sizes, and the fineness modulus of each aggregate. Finally, determining the correct proportion of each aggregate to fit a selected blend curve for the mix design. Correctly blending aggregates is the key to reducing costs and making the highest quality concrete products. Which brings us to blend curves. Blend curves are used to represent the overall aggregate mix design in a graph and help show how different aggregate particle sizes will fit together. These curves can help predict the overall performance characteristics of the mix design. When producing products that require high densities and low absorptions, like pavers or freeze-thaw durable SRW units, the ideal mix design curve has an M shape. The M-shaped curve has two peaks, one on the coarse aggregate and the other on the fine aggregate. That make the curve look like the letter M. Each of these peaks is very important to the performance of the mix design. The coarse peak helps provide strength and allows the mix to flow better and drive the mix into the mold cavities. The fine peak helps to fill the voids between coarse particles, helping to obtain low product absorptions and therefore increase density. In summary, changes in an aggregate will affect the performance of the mix design. Rarely will you be able to source the ideal aggregates to give you the perfect curve. That's why graphing and using multiple aggregates to compensate for that variability will help you make better concrete products. That's it for today. See you next time on ACM Shorts.